Looking at example 2, part A on section 3.2. I've already written up the work here. So basically we've got, it says find all the values x equals a where the function is discontinuous. And if you remember reading in the section about continuity and discontinuities, where do discontinuities occur? They happen when three different things. The first thing on that list is they occur where the function is not defined. So in this case, this function is not defined wherever the denominator would be 0. So in order to find that out, where the denominator is 0, I take the denominator and I set it to 0. And then I notice I have two factors set equal as a product set equal to 0. So I set the two factors separately equal to 0, and I get two different numbers, 0 and 2. That tells me that I have discontinuities at those two x values. And notice if you plug in 0 or 2, you're going to be dividing by 0, so you know you have a problem there. Now, to answer the second part of this, for each value of x, give the limit as x approaches a. So we want to find the limit as x approaches 0 and the limit as x approaches 2. One way to do that is just to look at the graph. So you can do that on your calculator or perhaps on the Desmos app. What you'll find is wherever the function is undefined like this and you can't cancel anything with the numerator, you're going to find that you have a vertical asymptote at that particular x value. So that means for this function, we're going to have an asymptote at 0 and then another one at 2. So I'll denote the one at 2 with this dotted line here. So, and then if you graph it on your calculator, what you'll find is that the function does something like this. And then between these two asymptotes, it does this sort of thing. And then on the other side of the asymptote, it does this. So what we can see is that as I approach, for example, the number 0 from the left, the function's going up towards infinity. But as I approach from the right, it seems to be going down to negative infinity. So what we can say about that is that the limit as we approach, as x approaches 0, for this function does not exist. That's because it's going to positive infinity on one side, negative infinity on the other. It's not approaching any number, and it's also not going to infinity on both sides, so we can't really say anything other than it doesn't exist. Then we can say, let me just sort of separate that, the limit as x approaches 2, well, that also doesn't exist. And for the same reason, because again, if you look, what's happening as I approach 2, the x value 2, what is the graph doing? It's going down towards negative infinity. As I approach 2 from the other side, what is the graph doing? It's going up to positive infinity. So it's doing opposite things on both sides. All we can say is that the limit doesn't exist. For part B, we have a sort of a different situation here. I'll try to squeeze B on here if we can. This one is shorter, so I think we'll be able to do that. We have the function f of x is equal to x squared minus 4 over x minus 2. Now in this case, again, the place that we will have a discontinuity is the place where the denominator would be 0, the x value that will make the denominator 0. So the denominator is x minus 2. If I set that equal to 0 and then solve, I'm going to find that x is equal to 2. So again, I'm going to have a discontinuity at x equals 2. That's the only one. However, in this case, what we'll find is that if I rewrite the function, I can do it like this. That numerator is actually the difference of squares, so it'll factor. So I'll have x plus 2, x minus 2 over x minus 2. And then if I take the limit of that, the limit as x approaches the problem value, x plus 2, x minus 2 over x minus 2. Now in this case, since we're taking a limit, we can just cancel these. We don't even have to look at the graph for this one. We've seen this before. If those cancel, then we're just left with the limit as x approaches 2 of x plus 2. And that, we can just do direct substitution, just plug in the 2. We're going to get the 4 there. So there is a discontinuity. However, the limit does exist. So what we see here is that the reason we have the discontinuity is because the function itself is undefined at 2. If I plug 2 into that thing, I'm going to be dividing by 0. So it's undefined. That's why there's a discontinuity.